Here we are, boys and girls, in the big 26, yet another method for some stranger to own your entire system through a single command, if even that. Who's at fault? Well, the blame is at least partly on this small-time company you might have heard of. I don't know, just a wild guess of mine. It's called Microsoft! Welcome to Level 1 Melon, where we cover tech security. Today I'm going to tell you about MiniPlasma, which kind of sounds like some weapon you might find in a boomer shooter or something. We'll get into how this exploit could impact you and your system, and what steps you might want to take in order to secure your computer from this 0-day for good, because waiting for a patch from Microsoft that won't break numerous other things is like... there's actual RNG involved now with updating your computer these days and hoping it doesn't break somewhere in the process. Like, holy. Also, you might want to stick around till the end because apparently there is drama between the talented researcher involved that disclosed a series of vulnerabilities and a big ol' Microsoft. Yeah, it's like microplastics. You can find drama anywhere. There's probably drama in microplastics. On to the important stuff. MiniPlasma is a fresh new 0-day that exploits a driver vulnerability on the Windows platform. It does this in order to sort of boost a user account with whatever privileges they may have, could be a guest account or an admin, to system level via a command prompt. The vulnerable driver in question is the Microsoft Cloud Filter driver, which is pre-installed as part of the Windows operating system's core components. Unlike some things in a modern OS these days, this driver is actually useful and has to do with cloud storage. MiniPlasma requires the Cloud Filter driver to be present on your computer. This is a kernel mode driver, which, if you're unsure of what that means it runs pretty deep in the computer, just like kernel level anti-cheat software that everyone loves. The Cloud Filter kernel mode driver is sort of like an executable, not in the sense that you could just go find it somewhere on your computer and double click it to run stuff like you would with any file with a .exe extension. This is a .sys or .sys driver file that's basically used and managed by the OS, and every Windows system out there has this driver pre-installed, as mentioned before. Even if all you intend to do with your machine is play Arc Raiders and whatever the new gacha slop is this month, the Cloud Filter driver file exists on your computer. Okay, then why does this driver file exist on my computer? What does it really do? Can I delete it? Maybe. Depends on what you use your computer for. If you're someone who uses services like OneDrive, iCloud, or Dropbox and frequently access files stored on the cloud through a folder on your computer, then you have a cloud storage setup that depends on this Cloud Filter driver. The Cloud Filter driver is what's responsible for managing file synchronization between your computer and the cloud server. This is how you can add, delete, or rename files stored on the cloud through your own computer by interacting with what are essentially icons called placeholders. All the updates and synchronization gets taken care of in the backend, and all you need to do is interact with those placeholders on a user-friendly graphical interface. I hope you're all still with me here as we dive a little deeper into which specific parts of the Cloud Filter driver lead to a total system compromise. So, the Cloud Filter driver is a file that's got a bunch of code inside of it called routines. If you're familiar with basic level programming, which I barely am by the way, routines are kind of like functions in a Python or C++ application. You could visualize them as blocks of code defined within the file that get unwrapped by the OS and then executed when called upon to perform certain tasks. One of the routines contained within the Cloud Filter driver is called HSMOS block placeholder access. Got it? Remember what I told you a minute ago about placeholders under the context of cloud storage? It is the icons you see on the OneDrive or iCloud folder on your computer that correlate with the files you've opted to store on the cloud platform. These make it look like you have the files on your own machine when they are in fact stored on the cloud server. So this routine accesses an internal application programming interface or API called CF abort hydration to perform its functions. Without getting too deep, an API is essentially a set of rules relating to how two different endpoints communicate with one another. You can think of it as a waiter at a restaurant relaying orders between the kitchen and the customer. It would be kind of chaotic if you think about it if customers had to each go into the kitchen to give their orders to the chef personally. Doubly so if the chef then had to coordinate and deliver each individual order straight from the kitchen to the right table. This is why we have a person called the waiter who helps facilitate food ordering and delivery. In the same way, it would be chaotic if a million different apps had a million different ways to talk to the operating system to access specific functions. So an API is what helps facilitate communications here. The MiniPlasma exploit takes advantage of the CF abort hydration API to convince the OS, because the OS trusts all internal APIs blindly, to sneakily plant dangerous registry keys in the .default registry hive. What's the registry? Well, the registry is that funny blue cube you click on to then go and add things you don't really understand in order to turn annoying things like Windows updates off, which I'm sure some of you are familiar with. A crude simplification of the registry would be a database of settings and configurations, I guess, and a hive in the registry is simply the top level group of objects, for example, hotkey local machine. I know HKey stands for handle registry key or something like that, not hotkey, but hotkey local machine sounds cooler. So once those malicious registry keys are added, the exploit program would then be able to spawn a command prompt with system level privileges. If you've ever had to launch the command prompt or PowerShell as an admin to do stuff, notice how the title bar specifically displays the role in the case of launching as an administrator. This means that the command prompt here is run under the context of the administrator and can perform functions with the same rights as an administrator. Well, the system role is hierarchically superior to the administrator in Windows. The administrator is essentially a user with rights or privileges to perform restricted actions. The system is a security principle that the OS itself uses, kind of like a special account. And this principle or special account has a special superpower called SE Impersonate Privilege, which basically means it can shapeshift and act as any other account on the computer to complete whatever task it needs to. Put another way, if the admin was the president, the system is basically God itself. I guess I don't need to tell you what sorts of things the attacker could achieve on your system with a command prompt that essentially has God mode turned on. Hold on a second, Mr. Melon. How would an attacker get into my computer in the first place, let alone plant a secret hack program that then messes with the cloud filter driver? If I don't download anything stupid, I should be fine, right? Nothing to worry about. To an extent, yes, being responsible while on the internet certainly helps when it comes to avoiding malware, but an attacker can slip the secret hack program or payload onto your computer or network of computers in many clever ways. To be fair, the secret hack program as is already got flagged by Microsoft Edge as I tried to download it from the GitHub repository, which is good. I'm pretty sure Defender would freak out too unless you go out of your way to turn it off, so the likelihood of you accidentally getting this malicious file onto your computer in the first place is pretty slim. However, it doesn't take much for someone to repackage the secret hack program and obfuscate the code in order to bypass simple signature-based detections and firewalls. Attackers and hackers and the evil people aren't looking for permission or consent anyway, and when they see poorly maintained and or configured systems out in the public, those things scream like an invitation. Here's a real-life example, so bit of a story time. I recently visited a convenience store that offered printing services. Next to the entrance was a printer that was connected to a basic desktop. On the monitor of that desktop was an open web browser with instructions and a QR code. It was written that for anyone who wished to print anything, they'd have to first obtain permission from the person in charge at the front counter before scanning the QR code to then transfer the files via WhatsApp. The first few things I couldn't help but notice were the Windows 8 start menu icon, the existence of Internet Explorer, and the network connectivity icon in the system tray showing internet access as being available. That is more than enough for someone with knowledge to wreak absolute havoc. There wasn't a whole lot to stop someone from just typing in a URL into the browser that would then connect back to a malicious server. I mean, the keyboard was right there under the screen. You could even hand the person in charge a USB drive and convince them that all the files that needed printing were on that device. The USB ports on the desktop were not locked or secured anyway. They were completely exposed, and maybe the machine itself didn't contain any sensitive information, but it is connected to a network. So if the person responsible for that system didn't bother to update it from Windows 8 to even 10, then I'm willing to bet that there isn't any sort of robust security solution in place either. An infected desktop used for printing could then become a vector for spreading malware to every device that would connect to the local Wi-Fi there. So yeah, there's a bunch of creative ways for an attacker to breach a system and gain a foothold. The MiniPlasma exploit is more of a tool for post-breach operations like privilege escalation, which it does pretty quickly, leaving you little to no time to react once things are set in motion. Alright, so we're gonna test out the funny thing over here, which is the exploit file. Everything should work as expected as soon as I double-click this to launch. I expect a command prompt window to pop up. I haven't tested this prior to recording this video, so we're gonna go in raw together over here. That is a sentence. The author did mention that it worked consistently on their system. This exploit file worked consistently on their system each and every time. That might not be the case for us because, as per their words, this exploit takes advantage of a race condition, which basically has to do with the timing of things. So if it doesn't work on this system here, it's probably due to the way I have this VM set up. This is a Windows 10 VM and it doesn't have Defender turned on. And I believe the cloud filter driver is somewhere over here. It should be. Let's do a quick check over here. Yes, it is. Maybe this might not work. We'll find out as soon as I just right click this and hit open. So we just hit run and then, oh look, things happening. Enforce token thread 6092 process 10 and then it's gone. Maybe it was looking for something over on the system 32 folder, didn't find it, and just disappeared after the fact. Let me see. Okay, so after some toying around trying to see if the cloud filter driver's location was the issue, it wasn't. I just had to like right click and set it to run as administrator, and then here you go. We are now the NT authority / system. Now from the attacker's point of view, they don't need this command prompt to be visible to do stuff. They can run this in the background in a sort of silent mode where it can just accept commands and then execute them without a graphical interface over here. So this can still be pretty deadly. It is pretty deadly. What should you or could you even do to mitigate this vulnerability? Well, nuking the cloud filter driver would be a choice, but not one I recommend, especially if you think you might want to take advantage of cloud storage at some point in the future. I mean, I'm sure you're aware of the absolute spanking deals that RAM and SSDs are going for currently. Keeping your Windows install up to date and applying patches as necessary should be the primary mitigation step, but that is a suggestion that feels more and more like a textbook answer that doesn't map very well to real life anymore. Especially these days, if you know what I mean, when it comes to Microsoft. I do kind of have a professional responsibility to recommend that you do keep things up to date and apply security patches, but personally, and this is my opinion, I would think twice about running Windows Update, especially on a machine that's used daily for things like work. Because here's the kicker, the vulnerability that enables the MiniPlasma exploit should have been fixed back in 2020. It was first reported by a Google researcher, so at least it was supposedly fixed back then. Even the researcher who exposed this issue was like, I got a heads up from my friend who told me to look into this, but I was like, nah fam, no way Microsoft forgot to patch this thing in the recent version of Windows or somehow lost track of it or removed it without telling anyone. Well, here we are. Sure, software is never perfect, I get it, but Microsoft has been going on a terrible streak recently to the point where I have personally stopped applying updates for a while now on my system and rely on alternate methods of securing the thing. I've told my friends who haven't moved on to Linux the same thing. I am of the opinion that if you have a backup in place or don't mind wiping the system and re-downloading all of your apps and games and you don't have anything sensitive stored on that specific computer, then dealing with even seriously nasty malware by the way of the nuclear option is far more practical than wasting hours, maybe even days, trying to troubleshoot your system after a borked Windows update. Or a Windows update that borked something else on your system, because that's happened too. And I'm not just parroting something I've read on the internet. I've been personally affected by one of these subpar updates a couple of months back where keyboard functionality was broken when trying to access safe mode. That was great. I can't say that Microsoft has been reliable when it comes to Windows as of late. I think it's been getting worse, but all of that is just entirely my opinion. You should do what you feel is best for your system, is the takeaway. Or you could just open the registry editor window and stare real close to make sure nothing funny gets added while you're not looking. Or you could always join the cult of the penguin. Jokes aside, if you're somehow watching this and you're responsible for an organization like a small medium business, for example, you should first not listen to me because I am completely unqualified, but one of the things frequently mentioned is to set up your EDR solution to monitor these specific registry keys for any unauthorized modifications. And since we don't know which versions of Windows are actually immune to this exploit, or if it will even continue to be immune in the future, maybe testing to see if mission-critical devices with the specific version of Windows they have on them is actually protected from the MiniPlasma exploit that probably wouldn't be a bad idea. For the rest of you lot, uBlock Origin plus keeping your anti-malware solution up to date, even Defender, goes a long way towards minimizing the chances of being compromised in the first place. So, on to the drama bit that I mentioned earlier in the video. I don't want to get too much into it because I haven't bothered to verify each and every statement. They're all words of the researcher which have been copied and reposted by multiple publications, so take them for what they're worth. I will say that if there is even a 1% chance of any of it being true, that would be insane. You can tell me in the comments how you feel about this part after we get through it. The researcher who disclosed the lingering cloud filter driver vulnerability, known as Chaotic Eclipse or Nightmare Eclipse, actually went on a sort of kill streak, if you will, beginning in April of this year. There was the Blue Hammer exploit, which had to do with local privilege escalation, so similar to MiniPlasma, CV 2026-33825 if you want to look it up and read more. That was then shortly followed by Red Sun, another privilege escalation vulnerability, and then Undefend, which I actually saw a headline about a couple of months ago or so, and had something to do with breaking Windows Defender, I think. It didn't stop there. Apparently this month alone, the researcher also disclosed the Yellow Key and Green Plasma exploits, and also released their proof of concepts. I'm starting to see a possible pattern here, I think, where the researcher might have looked at each quadrant of the Windows logo with so much hatred and then thought about cracking each one with a special exploit. I mean, the disclosures have sort of stopped, and they've certainly run out of colors on the Windows logo, so coincidence? The Bleeping Computer site reports that Chaotic Eclipse, the researcher, has previously stated that they are publicly disclosing these Windows 0 days in protest of Microsoft's bug bounty and vulnerability handling process. On the GitHub page of the researcher, where I got the proof of concept for the MiniPlasma exploit, they stated that normally I would go through the process of begging them to fix a bug, but to summarize, I was told personally by them that they will ruin my life, and they did. And I'm not sure if I was the only one who had this horrid experience, or a few people did, but I think most would just eat it and cut their losses, but for me, they took away everything. They mopped the floor with me and pulled every childish game they could. It was so bad at some point I was wondering if I was dealing with a massive corporation or someone who's just having fun seeing me suffer, but seems to be a collective decision. So yeah, those are some damning statements. I don't know what to say other than I kind of admire the researcher's ability to hammer a large corporation like Microsoft with vulnerability disclosures one after the other. Perhaps not in the way they decided to do so. I don't know if there's a problem with Microsoft's bug bounty program. There's probably details in the background that I don't care too much to get into for this video, because then it will just balloon into something else. So yeah, it is what it is. Well, I hope you found this video somewhat useful, if not interesting. If you'd like to support the work being done here, you could just simply leave a comment detailing your thoughts. I'd love to read them, or just say hi. Otherwise, I do hope I'll get to see you in the next video. Cheers!